All right, guys, so our help video for Unit 7 Progress Check Part A. So on question 5, you have a question that kind of looks like this. They're asking us to show that this is a solution to some differential equation, which is given here. All right, so what we're going to do is we're going to be plugging this in for the y here. And we're plugging something else in for the y prime, which we'll see in just a minute. The y prime, so if this is equal to y, then y prime would be the derivative of this thing, which is 4x. That was no square there. So that's what goes here. And now what we do is we just go ahead and simplify this. 2 times 2x squared is 4x squared. And this is 4x squared. And I forgot this 2 also multiplies the 5 there, so that's actually going to be a 10. And then these go away, and I'm left with this. And that's a true statement. Negative 10 equals 10. So that's the solution to the problem there. So that's how you could tell if a given equation is a solution to a differential equation. Now, for the one that you guys are working on, they give you 4 options, and I would just say start with option A and see if it works. If it doesn't, move on to option B, and if that doesn't work, move on to option C, and finally option D. Question 6 is pretty much the same thing. It's just that you have a little bit more to do. All I can say is that when you're doing question 6, make sure you don't forget to do the chain rule. Question 7 is the same idea, so we'll skip that. And then 8, 9, and 10, I'm just going to say go back to your Unit 7 review notes from last weekend and look at slides 8, 9, and 10. 8, 9, and 10. I think, yeah, 8, 9, and 10, that's it. So that's matching slope fields to differential equations. So just a whole bunch of those types of questions, and there's some examples that we went over too in those notes. So there's no interesting tricks on these, just pretty straightforward questions. So just look at those notes and you should be good. All right, let's move on to question 11 here. This one has an interesting little outcome. So we did a problem like this in class today. We want to find a general solution, which means we don't need to find a c value, but we do need to start by separating our variables. So I'll multiply both sides by sine of 5y, which will give me just sine of 2x on the left, and then sine of 5y on the right. And then we can also multiply by dx to cancel out the dx's. And that will give me this. So now I've successfully separated my variables. Now we need to integrate both sides. Now to integrate these, we're going to have to do a little bit of u substitution. Just buzzing through this because this is all old news to us. We've done this stuff lots of times. For this one over here, my u will be a different number. So for both of these integrals, now that we've done our u subs, we could take the 1/5 out like this, and we could take the 1/2 out like this. The integral of sine is negative cosine, so we have this. I'll put the u back in for this side, and I'll put the u back in for this side as well. All right, another little interesting twist and turn here is that they're going to want you to set it up a little bit differently. This is typically where we would just stop unless they wanted you to get y by itself, which would be pretty hard to do. Well, actually it wouldn't be too bad, but they notice how they have the answer choices set up here. So what we're going to do is we're going to, based on what we see there, we're going to we're going to add this whole thing to the other side. So we end up with negative 1/5 cosine of 5y plus 1/2 sine of 2x equals c. And then still we won't see our answer quite yet. So the trick on this one is to multiply everything to get rid of the fractions. So what can we multiply by to get rid of both 5 and 2? I think 10 would be a good thing to multiply by. So if I multiply by 10 here and here and over here, we're going to get 10/5, which is 2 cosine of 5y plus 5 sine of 2x equals, now over here, since this is just c, which represents some random unknown constant, if you multiply a random unknown constant by 10, you just get another random unknown constant. So they're just going to leave it as c in that case, even though it was multiplied by 10. And that means that this c value here is different than the original c value, but they're going to leave it as just c in that case. So that's this problem. So the trick about this one is you had to do u sub. That's one thing. The other thing is the setup. After you integrate, you need to rearrange the problem so it looks like the answer choices that they're giving you. All right, so let's go ahead and move on to our next problem, number 12. There's not a whole lot special about this one. I would say just make sure that I would say go back and see number 1 again. See number 1 on how to solve this problem. Okay, because we already did it in class today, and there's really nothing special about this particular problem, so I think we'll just leave it. Question 13, we did 12 in class. Also, in question 13 is just a lot like that one, so we'll leave it at that. Question 14 has an interesting little twist to it. So I'll show you the first step. The first step is to separate the variables. Well, the first thing we need to do, strangely enough, is we need to move the p over, because we do like to start with the dp dt all by itself on the left. Now that we've got that, now we can separate our variables. So I'm going to take the dt off this side and multiply it to the other side. And then I'm going to divide the 10 minus p on both sides. And so we end up with this. So this is how you will separate, excuse me. That's how you'll separate the variables. Then you're just going to integrate. This side will have a 1, and you're just going to integrate that with respect to t. This side, you're going to have to do you could do u sub, or I gave you a shortcut for these types of problems. I'll let you guys figure it out from there, though. All right, so this one's kind of weird. A lot of the steps are the same, but what's going to be weird about this particular problem is that for this one, you're not going to be able to actually integrate it because it's not an integrable function according to the strategies that we know of. So we're going to leave it in integral form. So I'll show you what I mean by that. But let's go ahead and just go through the motions like we're used to. So we want to find a particular solution, which means we need to separate the variables. So I'm going to move the dx to this side, and then I'm going to integrate both sides. Now if I integrate 1 dy, that's just going to be y. And if I integrate this, well, I can't. I don't know how to integrate that. Okay. So my y function, I'm not going to actually be able to integrate this side over here, but here's what I can do with my initial condition. We can kind of treat this like final amount equals starting amount plus that net change. So here's how we could put that c value in there, our starting amount. Okay, and then this is equal to 2. Oops, didn't want the equal sign there, it's just a plus sign. And there it is. So for this one, since we couldn't actually integrate this, we had to leave it as an integral. And since we left it as an integral, the way you incorporate your initial condition, instead of plugging it in to find C, you make that like your starting amount, making sure that these numbers here match, and then this part is 2. So that's how you handle that one there. Moving along. For question 16, I'm just going to say look back at number 2. We did that in class today. Let's take a look at question 17, and that'll be it for today because we already did 18 in class. The rate of change of y, so the rate of change of y with respect to t, that's what this means, is proportional to y. If y equals 0, I'm sorry, if y equals 20, when t equals 0, so let's back up here a little bit. So we know that this is the nice normal form. So instead of separating the variables and integrating, we could just jump right into the general solution. It's going to have that as a form. And they're telling us the starting amount is 20 when t equals 0. So that means that c equals 20. Now they say the rate of change of y is 10. So the rate of change of y with respect to t is 10 when y equals 40. Okay, so if I use this little equation right here, I can find my k. So let me get rid of that. I'll just start here with this guy. They tell me my rate of change is 40 when y equals, oh, I'm sorry, they said the rate of change is 10 when y equals 40. So how can I solve for k? I would just divide by 40. And I get 0.25. Okay, so now I know my k value is 0.25. So that was a different way of finding the k value. The one we did in class earlier today, we plugged in a y and a t value to find the k. But with this one, we didn't know the y and the t. We knew the rate and the y. And for that, we had to use this one to get the k. So there's actually 2 different ways you can get your k value now, we see. But in any event, that's how you do it. So we started off, that's pretty standard. This is pretty standard, and this is pretty standard. The trick here was finding the k value by going back to this equation instead of this equation. Okay, so that was the little twist on that one. All right, so hopefully that was helpful, and we'll see you guys in class tomorrow for some more practice.